Hello, welcome back to SCI Teach. This is a tutorial video on mass and volume relationships. Mass and volume relationships. So what is mass and volume relationship? Mass and volume relationship is a relationship formed between two species where the mass of one species and the volume of another species is the basis of the relationship between those two species. So that means you have mass of one of the species, and you can then be asked to use that mass of one species to find either the mass of another species or the volume of another species. If you are asked to find the mass of another species using the mass of a known species, then you're going to use molarity to find the number of moles, amount, which is mass or reacting mass all over the molar mass, to find that. But if you are asked to find the volume of another species using the mass of the known species, then you're going to use a gas law. That's Avogadro law, which says that 1 mole of an atom or 1 mole of any substance contains 6.02 times 10 raised to power 23 particles of that substance. And if that substance is a gas, then that 1 mole will fill up a space of 22.4 dm cube. So 22.4 dm cube is going to be used if the species is a gas. Now, before you can solve mass and volume relationship, you must first of all balance your equation. Why? Because a balanced chemical equation tells you the relationship of the amount of reactants to one another and to the product. So it's in a balanced equation that you will know the mole relationship between the reactant molecules and also the relationship between the molecule reacting and the product formed. So you must first of all balance your equation correctly for you to solve mass and volume relationship problems. All right. So we are going to use examples to understand the topic well. We have a question here. Determine the mass of carbon dioxide produced on burning 104 grams of ethane. Determine the mass of CO2, carbon dioxide, that is produced when 104 grams of ethane, C2H2, is burnt. And you are given the relative atomic masses of carbon to be 12, hydrogen to be 1, and oxygen to be 16. Now, remember I said a balanced equation is very important. So we must first balance the equation. Now, this question didn't give you any reaction equation. So we have to create a reaction equation from the reaction we see in the equation. So we are told that ethane was burnt. So we write ethane, the formula for ethane, C2H2 first. And then for something to be burnt means that thing combines with oxygen. So in chemical way of writing, if we say something is burnt, it means that thing plus oxygen gas. So we write ethane, C2H2, plus O2, oxygen gas. And then it produces carbon dioxide from the equation. And if we recall from hydrocarbon, we remember that when hydrocarbons burn in air, they produce carbon dioxide and water. And from the equation, we've seen that carbon dioxide was produced, but we didn't see water. So we know that water also will be produced. So on the product side, we write CO2, carbon dioxide, plus H2O, water. So our reaction equation is C2H2 plus O2, CO2 plus H2O. C2H2 plus O2 yields CO2 plus H2O. And we have to balance the equation because it's not balanced. If we balance the equation, the reaction equation will become 2C2H2 plus 5O2 yields 4CO2 plus 2H2O. That is to say, 2 moles of ethane combined with 5 moles of oxygen gas to produce 4 moles of carbon dioxide and 2 moles of water. So we have balanced the equation. So we now know the mole ratio of what we are given to what we are looking for. Now, if we look at the equation again, we're given the mass of ethane. So that's the known species. C2H2 is known. The mass of C2H2 is known to be 104 grams. We're given in the equation. We're asked to use that species to find carbon dioxide, which is in the product side. And we don't know anything about that except the mole ratio. So we're going to close our eyes to other species, that is O2 and H2O, and open our eyes to only the species that we are looking for and the one we are given. So we are concentrating on C2H2 and on the product side CO2 because we are asked to use ethane C2H2 to find carbon dioxide CO2. But this case is very simple because we're given mass of C2H2 and we're asked to use that to find still mass of carbon dioxide. So mass to mass relationship right now. That case is not going to be difficult at all. It's just for us to compare and then we calculate. Right? So let's solve. So we have to analyze and convert C2H2 to the number, to the mass. That is, C is 12 and H is 1. But we have 2 moles of C and 2 moles of hydrogen, and all of them times 2 because there are 2 moles of ethane. So we say 2 into 12, that's carbon, times 2 because there are 2 carbon atoms, plus 1 times 2, 1 of hydrogen, and times 2 because there are 2 hydrogen atoms, and all of them multiplied by 2 because there were 2 moles of ethane. If we calculate that, 2 into 12 times 2 plus 1 times 2, we'll find we have 52 grams. So we are saying 52 grams of ethane. We write that under ethane, under C2H2. Now going to the product side, we're looking for carbon dioxide. We do the same thing. C is 12 and O is 16. So we say 12 plus O is 2 atoms there, so 16 times 2. C is 12. 12 plus 16 times 2. And we multiply everything by 4 because there were 4 moles of this carbon dioxide. And if we do that, 4 into 12 plus 16 times 2, we'll find that we have 176 grams of carbon dioxide. So comparing the masses now, we are having that 52 grams of ethane yields 176 grams of carbon dioxide. So we'll be asking ourselves, if that is, if 56 grams of ethane yields 176 grams of carbon dioxide, then what will 104 grams of ethane, as given in the equation, yield? We put that in mathematical form and say 52 grams of ethane yields 176 grams of CO2, then 104 grams of ethane will yield X, and we cross multiply and find X to be 176 times 104 all over 52. Then we discover from calculating that 104 grams of ethane will produce 352 grams of carbon dioxide. So it's as simple as that. Balance your chemical equation, use the mole ratio, to compare what you have with what you were given, convert them to the masses, and then compare and find what you want. The next question is, consider the reaction 2NaCl plus H2SO4 yields Na2SO4 plus 2HCl. In this question, we are given the reaction equation. So we don't have to find it, but we can then confirm if it's balanced or not. But it's balanced right now. And we're asked to calculate the volume of HCl gas that can be obtained at STP from 5.85 grams of NaCl. Now, this one is mass volume relationship problem, because we are given the mass of one species, NaCl, and we are asked to find the volume of another species, HCl. Remember, we said if you're asked to find volume, then that species is going to be a gas, and HCl is gaseous. And remember also, we said if it's a gas, then we'll have to apply the molar volume rule, that 1 mole of any gas occupies 22.4 dm cube space. So remember, your balanced equation is important. That is 2NaCl solid plus H2SO4 solid yields Na2SO4 aqueous plus 2HCl gas. So we write that out clearly, and then we start our comparison. Now we are given NaCl, the mass of NaCl as 5.85 grams, and we're asked to use that to find the volume of HCl on the far right. So we close our eyes to other species that we don't want and open our eyes only to the species that are important for this question. So we close our eyes to H2SO4 and Na2SO4 and only concentrate on NaCl and HCl. So under NaCl, we see we have 2 moles. So we write there 2 moles. And then if you calculate the mass of NaCl, you're given the relative atomic masses of Na to be 23 and Cl to be 35.5. If you join that together, that is 58.5. So that means 1 mole of NaCl is 58.5 grams. So the 2 moles given to us in the equation has to be 2 times 58.5 grams, which gives us 117 grams. We put that under NaCl. Then go to the HCl that we are asked to find. We see we have 2 moles of HCl, so we write under it 2 moles. And then remember from Avogadro principle that 1 mole of a gas occupies a space of 22.4 dm cube. And if we have 2 moles, like in this case, then it has to be 2 times 22.4 dm cube, which is 44.8 dm cube. We write that under HCl. So now we're going to compare and say if 117 grams of NaCl yields 44.8 dm cube of HCl, then what would 5.85 grams of NaCl that's given to us in the equation yield? So we put that mathematically and say 117 grams of NaCl equal to 44.8 dm cube. Then 5.85 grams of NaCl equals to X of HCl. So we calculate that to have that HCl will be 44.8 times 5.85 all over 117. And we have that 2.24 dm cube of hydrochloric acid gas was produced in this question. All right, so as easy as that also. The next question is this: if 0.20 mole dm cube of NaOH was evaporated to yield 5 grams of solid NaOH, calculate the volume of NaOH in aqueous form used. We're saying if 0.2 mole dm cube of aqueous sodium hydroxide was evaporated to yield 5 grams of solid sodium hydroxide, Calculate the volume of aqueous sodium hydroxide that was used. And sodium is 23, oxygen is 16, hydrogen is 1. Now, we look at the question and we see that in this question, sodium hydroxide is on the left, and then sodium hydroxide also is on the right of the equation. It is not the equation you would be thinking of, like a balanced equation. No, it's just sodium hydroxide we're having in view here. But one is in aqueous form in solution, and then it was evaporated. The water was evaporated until the solid sodium hydroxide was formed again. Okay, in the right hand side. So we are just looking at what is given to us. Now, we know that we're given 5 grams of solid NaOH. So that's our datum. We use that as reference. And then we're asked to find the volume, that's in dm cube, of aqueous sodium hydroxide used. Now, we have to first find the number of moles of this solid sodium hydroxide. We're given 5 grams, and to find number of moles, the formula is amount, N, equals to mass, the reacting mass, all over the molar mass. So what is the reacting mass? We are given as 5 grams. And what's the molar mass of sodium hydroxide? If Na is 23 and O is 16 and hydrogen is 1, that's 23 plus 16 plus 1. That gives you 40 grams. So number of moles equals to 5 all over 40, which gives us 0.125 moles of solid sodium hydroxide. Now recall, for the aqueous sodium hydroxide, we are given 0.2 moles. And look closely in the equation, you are told that 0.2 mole dm cube. Dm cube means 1000 cm cube. So what it means is that this 0.2 was dissolved in 1000 cm cube of water. That's the standard. That's what the dm cube is doing there. So you show that in your question, in your explanation, and say 0.2 mole sodium hydroxide dissolved in 1000 cm cube. And then 0.125 mole would dissolve in what? That's a comparison now. So we are saying if 0.2 mole sodium hydroxide dissolved in 1000 cm cube, then what would 0.125 mole sodium hydroxide dissolve in? We put that mathematically and say 0.2 mole NaOH equals to 1000 cm cube. Then 0.125 mole NaOH equal to x cm cube. So we make x subject of formula, and we see that x will be 0.125 times 1000 all over 0.2. And we find that x equals to 625 cm cube. That means that the volume of aqueous sodium hydroxide used was 625 cm cube. Okay, now what we basically did was, because the sodium hydroxide on the left hand side or the other side of the equation, the solid sodium hydroxide was given in grams, we can't directly compare something in grams with something in moles. We either have to convert what is in gram to mole so that we compare it with the other mole, so mole to mole, or we convert what is in mole to gram so that we compare the both grams. So in this case, we had to convert the mass of sodium hydroxide that was given 5 grams to mole. With that, we were able to use it and compare with the number of moles given to us in the equation of aqueous sodium hydroxide before we could find our answer. It's very important to take note of those things. All right, so once you're able to do that, what is left for you to do is just to compare two of them. If this produced this, then what would this given to you in the equation produce. You put that mathematically and solve, and you will have your answer. The next question. Consider the following reaction equation. C2H4 gas plus 3O2 gas yields 2CO2 gas plus 2H2O liquid. What will be the volume of oxygen at STP that will be required to burn 14 grams of ethene? So the reaction equation again is ethene gaseous plus oxygen gas gaseous yields carbon dioxide, 2 moles of carbon dioxide gaseous, and 2 moles of water in liquid form. And we are asked what's the volume of oxygen at STP that would be required to burn 14 grams of the ethene in the question. Now, the molar mass of ethene is 28 given to you in the question, and the molar volume of gas at STP is 22.4 dm cube. These things given to you already sometimes gives you hints. Like in this case, you know that you are going to use 22.4 in the equation. So it makes it a little easier for you. All right, so we look at that equation, which has already been given to us, and check if it's balanced. And yes, it is. The balanced equation is C2H4 plus 3O2 yields 2CO2 plus 2H2O. Now we start the analysis. What we are given is ethene. Okay, we are given 14 grams of ethene, and we are asked to use that and find the volume of oxygen, O2. So in this case, what we are looking for is O2, which is also a reactant, and we are using what we have been given, C2H4. So that means we close our eyes to the products and just concentrate on the two reactants, one being C2H4, which is known, the mass of that one is given to us. And we're asked to use that and find the volume of the next reactant there, oxygen gas. So we see that 1 mole of ethene combined with 3 moles of oxygen gas. That means 1 mole of ethene was required for 3 moles of oxygen to burn completely ethene, yes. So 1 mole of ethene from the equation is 28 grams. So we write under ethene 28 grams. And then oxygen, 1 mole of any gas will fill up a space of 22.4 dm cube. And now we have 3 moles here. That means 3 times 22.4 dm cube of oxygen. Right? Which is 67.2. So we are comparing now. We are saying if 28 grams of ethene was required to combine with 67.2 dm cube of oxygen, then 14 grams you'll require what? And then we solve that, as we call, put that mathematically and say 28 grams of ethene equal to 67.2 dm cube. Then 14 grams will be equal to x. We make x subject and solve. We find that 14 grams will require 14 times 67.2 all over 28. And we discover by calculating that we'll have 33.6 dm cube of oxygen. That means the volume of oxygen at STP that was required to burn 14 grams of ethene is 33.6 dm cube. So you discover that mass volume relationship problems are actually easy. Now the last question. The mass of potassium hydroxide required to make 300 cm cube of 0.4 mole dm cube solution is what? So you're asked to find the mass of potassium hydroxide that is required to make 300 cm cube of 0.4 molar dm cube solution. So in this case, we are given 300 cm cube of 0.4 mol dm cube solution. Remember from the last two questions I said the dm cube there shows you that was standardized. It was dissolved in 1000 cm cube of water. That means this 0.4 mole was dissolved in 1000 cm cube of water. So your question is, if 1000 cm cube contains 0.4 mole, then 300 cm cube will contain what? And then you put that mathematically. 1000 cm cube equals to 0.4 mole, 300 cm cube equal to x. You make x subject, and you find that x will be 300 times 0.4 all over 1000, which will be 0.12 moles. Now you've converted to moles. Remember, you're not asked to find moles. Okay? You're asked to find mass, the mass of potassium hydroxide. So we go ahead and use that mole to find the mass. Remember that formula for number of moles is amount, N, equal to mass all over molar mass. So we can make mass the subject of equation there and say mass is going to be number of moles times molar mass. That's amount times molar mass. The number of moles we just found, 0.12, times the molar mass of potassium hydroxide, which is 56. So 0.12 times 56 will give you 6.72 grams of potassium hydroxide. So that's the answer, 6.72 grams. So you've seen how mass and volume relationships are. As a summary, things to note is that you understand how to write a chemical equation even when you are not given an equation. You can look at the statements in the equation and form a chemical equation. And then balance that equation, because if it's not balanced, you will not know the moles of reacting molecules. And when you balance the reaction, find out what species is known and what is given, if it's mass or number of moles of volume. So you find out the mass or the volume of the known species. And then what species are you looking for? Then you close your eyes to other species and concentrate on those two species, the one you are given and the one you're looking for. Compare their mole ratio and then analyze them, and then ask necessary questions, cross multiply and solve, and you'll have your answer. If you have any question, use the comment section and I'll be very happy to reply you at my earliest convenience. Thank you for watching, and please remember to subscribe to this channel and hit the notification button so you can get notified on any new exciting educative resources that drops. Share this video to your friends that need help in mass and volume relationship, and then as you study, you will understand and ace your exams with flying colors. Thank you. God bless you.